Yeah, I did now, but I'm not getting any input. Like it's saying it's getting input, but it's not showing anything.
Okay, so as a backup, let me see if I can record. Oh, I am not the host. Sorry.
We have output now. Something is working.
Yeah,
it's working.
I did now.
Can somebody? I'm not getting any input. Like it's saying it's getting input, but it's not showing anything.
Yeah, it is. It is showing to me now. I can see it.
Anyways, using Zoom, yes, a backup.
Yeah, I've just listened to myself talk, so it's working.
All right. Thank you so much for the patience. We are finally ready to start the July 3rd IPFS Allens. Hi, everyone. I'm David. I'm going to be the moderator for today. We have Friedel, who is going to be the note taker. As usual, feel free to add items to the agenda. One of the items that was added, especially to this agenda, was a roll call, bring back the roll call, since we have so many new faces. As a tradition, let's go from west to east, which I believe it means it starts with you, Kuba. Would you like to start?
That's east to west.
That is true. I as a tradition, I got it wrong.
Hello. Okay. Now Mike is going to this room. Hi, I'm Kuba Kubuksu. I work for Protocol Labs on Go IPFS and connected projects. That's in short terms. Thank you.
Could I interrupt just a moment? Are we going to record this? Doesn't show recording.
Yeah.
Okay. Perfect. Thank you.
Let me share with you and with everyone in the group the link for the live stream. I'll put it here on the chat and IRC. Okay. We can continue with the roll call. I'll just paste the link here. Bart, would you like to go next?
Oh, okay, yeah. Sorry. I'm Lars. I live in Berlin, and I work on the IPFS infrastructure, the peer-to-peer, and Go IPFS.
Hi, everyone. I'm new to this call. I'm Drew Winget. I'm a software engineer with Stanford Libraries, and we're experimenting with IPFS for annotations and research data sharing.
Hey everyone, I'm Friedel. I work for Protocol Labs. I'm your note taker today, south of Germany, and I work on JS IPFS and Go IPFS and various things everywhere.
All right, I can go next. Hi, everyone. David, moderator for today. Work for Protocol Labs and focus on JS IPFS and Lib peer-to-peer.
Hello, my name is Victor. I work with Protocol Labs as well. I live in Barcelona, in Spain. I work on JavaScript things and infrastructure things as well.
I think that's me now. Okay. Hi, everyone. I'm Pedro. I work for Protocol Labs. I work mainly on JS IPFS and some IPFS lab stuff like CRDTs related. And I think that's it.
I think the last from Europe is Ed.
Hey, I'm Ed Silverton. I work at a company called Holocene. I'm lead developer of the Universal Viewer project. I'm very interested in extending IIIF into sort of 3D and holograms and things like that.
All right, thank you. Let's go over the ocean. I think the first one from the US is Matt. Yeah.
Matt Zoma, I'm with Protocol Labs. I tend to the overall organizational roadmap of IPFS, among many others.
Why are you sleeping? I'm on the East Coast today, so right next to Matt. And yeah, I work on Go IPFS and other things that are also in Go.
Hi, Herman Junge. I work in Consensus and working on the Ethereum browser-like client on top of IPFS.
Might be me, I'm not sure. But I'm David Grisham. I'm at Colorado School of Mines, and I'm researching BitSwap, working on Go IPFS and BitSwap, and also working on IPFS cluster.
I am probably next. My name's Jay Carpenter. I'm interested in naming, addressing, and numbering and identity, and I'm working with a group of people here in Phoenix, Arizona. We're working with WebRTC and IPFS and looking to do some interesting peer-to-peer connectivity items.
I'll go next. My name's Jason. I'm working on some WebRTC stuff, some peer-to-peer stuff, and some blockchain stuff.
Cool. Hey, I'm Kumavis. I'm in Seattle. I work on Ethereum, especially on MetaMask stuff, and currently working on some Ethereum IPFS integration with Herman.
Due to awkward silence earlier, I jumped the gun, but I'll just say I'm in San Francisco.
All right, thank you. Anyone else?
Paizo.
Yeah, I'll say hi too. So, sorry to interrupt.
No, please be welcome. Thank you. Thank you for joining. All right, so if we don't have any more introductions for now, you can change your mind. Let's go into the second item of the agenda, which is waffle board. So a while back, waffle board added by me. So that's the word to me. A while ago, we started using the waffle board. So if you go to things like waffle board, waffle.io, IPFS/JSIPFS, you can see like issues that the team is currently active, like the contributors are currently active working on the in progress column. Like a lot of people ask through IRC or through Twitter, what are people focusing on right now? And like the waffle board is a perfect place to get a sense of what is the current focus of a specific endeavor within the whole IPFS project. There's a waffle board for only peer-to-peer. There's a waffle board for just IPFS, and one for Go. Not all of the waffle boards are updated like live. It requires some time for us to actually go through all the issues. We try to be as diligent as possible to make sure they are up to date. But even if they are not like 100% up to date, they are still a very useful tool. And you can help us triage some of those issues if it's something that is interesting for you as a contribution to help us identify what are the ones that are like bugs, what are the ones that are questions, provide answers to the ones that are questions that have been already answered, or just like make sure that people get the attention they need on all of those issues. In just IPFS specifically, even like I've been doing this weekend, like cleaning up all of it, you can find a bunch of issues on the ready column, which typically means it is issues that have been identified as like things that would be great if someone was working on. They are just not active because someone, like the rest of the people that are actively contributing, are already busy with the in progress. The flow is as soon as you finish something on the in progress, you pick something from the ready column. And if you get blocked in something in the in progress column, you move it back to the ready or to the backlog, and then you pick some other card. This way, it's like a way for us to be all in sync. I just like wanted to like. We have talked about the waffle board extensively during the first quarter of this year, but like since we haven't brought it up for quite some time, I thought it'd be useful for everyone. And that's it. Cool. All right. If no one has questions on that, let's jump into the demo section. Are people here for the demos? I've been saying that there's like some exciting demos today, and I see my marketing strategy worked. We have a call full of people. So yeah, like we have 2 exciting demos today. I'll just like let the owners of the demo to take it away and explain what they are going to show. Drew, Ed, and Pedro, do you want to be the first one?
Sure. So Ed is gonna walk us through the demo for the most part. We're gonna be filming from his machine. How should we do that? I guess Ed will share his screen.
Well, I'll share my screen, right? I think this whole thing is being recorded. Is that right?
All right, that works.
Yeah. Cool. Right, I'll just go ahead then.
So for a little bit of context while Ed gets set up, I work at Stanford, where I've been the developer of a research tool called Mirador, which allows researchers and students to build or to view and annotate high-resolution imagery. And Ed has developed a similar viewer for a lot of cultural heritage institutions in the UK called the Universal Viewer. And both of these viewers rely on a standard that was developed by an international community of cultural heritage institutions called IIIF, or the International Image Interoperability Framework. And the set of standards that's been developed allows annotations that are created on in one viewer to be viewed in another because of the interoperability between them. So what we've set up here is a demo in which Mirador, which has an annotation creation tool, will create annotations on an object that gets propagated through IPFS to the universal viewer where it can be viewed.
Yep. So this is the repository. So we've got this organization called Viewder. I think we decided in a row we're going to rename this actually to IIIF Labs or something like that because it's less confusing. But yeah, if you go to Viewder/IPFS experiments, we're thinking this is just going to be like a general repo for any IPFS related experiments we do. And then it's in viewer annotations. And the setup's pretty straightforward. My browser's pretty slow. You just clone it, npm install and npm start. And when you run npm start, fires up localhost. And then you get a page where you can choose UV and Mirador. So if you just open those, it's quite important currently to open these in new windows because of limitation. Pedro would need to explain this, but it's related to sandboxing or something like that. I don't know. Pedro knows. But
yeah. Well, I'm not exactly sure about the whole story, but the symptom is that using WebRTC with Chrome throttles the processes that are behind the resources and processes that are behind the not viewed. So in order to run these and propagate the changes in real time, it works best if you just have and it's separate windows and they are on top. They are not hidden. They are not fully hidden.
And to clarify, this is just so that you can do a demo, right? If you're
Sure.
doing a demo where if you have both screens open, in order to get it to perform right, you need to have them be in separate windows that are not overlapping. The actual functionality, if you were actually using this in a real situation where each viewer is on a separate machine, you wouldn't have this issue.
Yeah.
Exactly.
So on the left, we've got Mirador.html, and on the right, we have uv.html. So if I add an item, these are both kind of configured to only be interested in one specific IIIF manifest, which is this one. So if I've opened this in Mirador, and then if I scroll down here, I've got a connect to IPFS button in the UV. And I'll just scroll over slightly. So if I now add an annotation and select a rectangle that only works with rectangles, and select that area. Save that. See, it immediately appears in the other window, and then if I mouse over that, it's added. So I can just go ahead and go to a different page and take something else. You can see down here, so apologies for the limited screen real estate. So you can see another annotation's appeared here. I'll click on that, and then see it's zoom. It defaults to zoom in on the first annotation. That's because the UV is kind of using annotations primarily for search results at the moment. Yeah, so I can then just keep annotating.
And this is really significant for our sub-community of technologists, because currently there's a lot of controversy or confusion over where these annotations are supposed to go or who's responsible for them once they're created. So libraries don't really have annotation servers right now that they run as a matter of course. And a lot of the users that, that rely on our software aren't that technically savvy, and most of them aren't going to set up their own annotation server or even necessarily plug into various services that could someday be adapted or configured for that. So this solves a major problem by letting IPFS run in the browser directly with JS IPFS, and the annotations are just stored, and the user doesn't really have to think about how they're going to get around and get shared and republished. Anyone who's subscribing to that channel, who has a certain link, essentially, can easily view those in real time.
So these are just like peers, and then you could easily set up a third peer. And we have an example of that actually, where it can track the annotations being created and preserve them. So that's really useful. You could imagine a scenario where you've got a room full of people and they're all annotating away, and then Stanford are preserving those annotations for them, or multiple institutions are tracking that kind of partition or unique ID that the annotations are being saved under and preserving them. So currently, if I were to close both these windows, then all the annotations sort of disappear because they're only kind of being persisted in a CRDT that's between these two windows. But that, doesn't mean you can't have a third peer that's keeping track of it.
Yeah, that's right. So that extra node or those extra nodes are just another node in the network, really. They're just persisting the changes as they see. And this is implemented in a way that allows multiple writers on the same document. And this is achieved using CRDTs. If you're more interested, I can give you some pointers to the libraries that we're using to implement this on top of IPFS. Some of them is to create a room out of just a topic, a pub subtopic. And the other one is to just create a CRDT using a connector, IPFS connector of a YJS, which is a CRDT library. That really allows several writers on the same data structure in a way that is conflict-free. And the persistence, right now it's because we're just demoing, it's not persisting the data in the browser, but it's just an option on the library to persist it. And that's what the third or fourth nodes, if you want, could do, which is track the changes on any document and persist them locally, so they are available if any of these participating browsers close, they're still persistent, they're still available on the network.
Yeah, so let me just, for if anyone is confused about the flow of what's happening there, this is using IPFS PubSub underneath. So both of these viewers I have chosen before. It's currently hard coded into the code. They've chosen an identifier for the channel that they're publishing these annotations on. And each of these windows currently is running its own IPFS node, a JS IPFS node in the browser, in the window. And so there are what you're looking at is the viewers, which are each running an IPFS node. And when you write an annotation in Mirador, it's writing that annotation to that IPFS PubSub channel. And the only other node on the network right now that's listening on that channel is the other window, is Universal Viewer. But what they're talking about is like you could have 100 nodes listening on that channel, on that PubSub channel. It's just that right now we only have 2. And since there's only 2, and the information is only being written into those 2 IPFS nodes, if you close these browser windows, you lose those nodes and you lose the information that those nodes are holding. But then we have tons and tons of options how you could store that information otherwise, just by running other nodes.
Ed, is the tracker still available?
What's the URL for that again? Sorry.
Should be. Yes.
There is now a new organization on GitHub called, it's set up like being just IPFS. It's IPFS-Labs. We are trying to pick up a better name for it, but GitHub will do redirects. So if you go to github.com/IPFS-Labs, you will see a bunch of those building blocks for real-time applications on top of IPFS that are using just IPFS and only peer-to-peer PubSub with CRDTs and without CRDTs.
Trying to remember the URL.
So this tracker that Pedro built
is there as well, I think. Right?
Yeah, I'll paste you the link.
Yeah, it helps visualize the kind of 3rd, 4th, 5th N node idea for libraries and cultural heritage. What all the IPFS people in the know are thinking about that is that hopefully down the line, libraries will be these kind of backup listeners to a lot of small research group activity, and they'll have command line tools that run in the background to listen on these channels and persist research data. So, and like provide it over APIs and things like that for additional research, and handle the kind of official archiving of the data passively in the background. So this is an example of how such a command line utility would work. It's just going to log out the messages for us.
Just restarting the peers.
Mm-hmm.
Yeah, so for example, if you were a researcher at a research institution, you would basically just have to tell the library what channels you're using to create this data that the library should be collecting, and then the library can just add it to the list of channels that it's following and archiving. So it becomes, there's no like stop and upload all of your data to the library system. It's just make sure the library knows where you're having conversations and where you're creating data, and it all gets pulled in and archived appropriately.
Mm-hmm. Currently, that's an extremely high friction process.
Just trying again. Bear with me.
Any questions while Ed gets things set up? I'm trying to see if there's like
there
any.
We go.
Okay, there you go.
Lots of peers.
I'm running one.
Yep.
Yeah, I also opened the page in my machine.
Probably everybody at this point.
That's good.
So if I create another one.
Thank you for backing Ed's annotations. You are doing a favor to mankind.
There you go. Test. What? Just do another one. There you go. Just tracing out the the annotation list items.
Yeah, so these are all the events happening, and our virtual library server can save those and archive them in whatever way it sees fit.
Yeah, it's tracking. Basically, it's tracking it, as Matt said, pub sub channel, and logging every change on a CRDT over that. So pub sub channel is just a way to transmit the changes and broadcast all the changes to all the listening peers, and the tracker is just one of them. And the tracker is just logging when a mutation event happens, basically.
I mean, I could share the code a bit if that's of interest.
And I guess like one interesting thing to note is like all of the annotations data model was already built beforehand, and it was using JSON-LD. And right now it's like being put into IPFS using the DAG API with DAG CBOR. So there was no need to like change the object. It was just like DAG put the JSON blob, and you got the Nash back.
This is what the JSON looks like. This is an annotation list. This is based off the open annotation spec. Future of IIIF will be to use the web annotation data model, which is a bit different to this, but this is the purpose of the demo. And the UV and Mirador only support this currently. But the web annotation data models are really, kind of quite generic. So you can annotate, anything with it conceivably, really, like time frames of videos or regions of text or images or any kind of media. Yeah, so it's not limited to this use case, really.
All right.
Yep.
Yes. Anything else to show, Ed?
Well, just the code, really. I just wanted to show how easy it is to include this in your page. It's just coming from unpackage.com. We've got this kind of browserified distribution file. It's absolutely great because we started off using Drew and I experimented a bit with Orbit, and we found it slightly difficult to get started with, and I think that kind of began the process of talking to the IPFS team a bit more and experimenting. And this is kind of like the ideal scenario as I think Drew sees it too. I just want to include that, and then I've got access to the peer-to-peer universe. But it's not that simple. There's other stuff going on, obviously, but that's quite nice.
Pedro set up the API very nicely, though, because, I guess first of all, to say another note on distribution, it's also an NPM, so we could just just as easily compose it into a larger application. So Mirador recently released a desktop version that runs inside of Electron, and that's a really good candidate for including IPFS IIIF DB over NPM, and then all the data that's created there has a place to live, even though it's not not in the browser, and it can be shared easily.
And then this is where it's getting set up. You're initializing the IPFS IIIF DB object, and then waiting for it to be ready, and then creating this annotation list object, which is kind of the container for all your annotations. And it's using this @ID property to kind of set the unique endpoint for the annotations to be created against. And then we had to do a bit of code to kind of massage the data a little bit, because UV thinks slightly differently to Mirador about annotations. But yep. I guess that's it.
We're going to crack open the Mirador code to show writing really quick. So Mirador has this, if we just scroll actually down to the bottom there. So they're under annotation endpoint. This is the Mirador instance configuration object. It lets you kind of set up what the workspace is like. On that line 59, you see annotation endpoint, and we're supplying a module. So that's been released into the namespace as a JavaScript object, this IPFS endpoint. And Mirador is going to take that and it wraps it, and there's a standard kind of API for that. And IPFS just provides the implementation for each of those methods. So if we scroll up slightly in this file here, you'll see this is how this is again the DB initialization. So it's same as for Universal Viewer. We set the ID and the channel and give it the initial kind of container annotation list. And then it goes into this constructor for IPFS endpoint. So we pass in the initial DB instance, and that's what Mirador is reading off of itself in order to use the annotation endpoint. So going into the annotation endpoint code, just provide this module, and it just accepts the instance and kind of sets some properties there, and we just have basically CRUD methods, create, read, update, destroy. We're calling it search for read, and so this is the writing portion, the create here. We're doing some logging for demo purposes, and then it really was just as simple as typing, push resource, and it just works basically. We just push it onto the CRDT, and that's it.
Bit like magic, isn't it?
Yeah.
If you're also interested in the underlying code of this, there is kind of new GitHub organization called IPFS Labs.
Mm-hmm.
So this is where some code that allows this lives, namely by IPFS connector, the connector for YJS, which is a CRDT library that I told you before, and IPFS pub subroom, and the IPFS reply FDB, which is directly what Drew and Ed were using to integrate.
Cool. So am I done? So everyone, any more questions or?
Let's see if there is hands. I'm like scrolling. I think you can stop the screen share now, so you go into grid view. But yeah, if there is no questions, thank you so much, Ed, Drew, and Pedro for building and coming up today to show it working. It was super exciting.
Super cool.
Yeah, exactly. Yeah, seeing annotations over these very important documents at the Vatican conference, all of these historians, researchers, people coming from all different areas and institutions being their minds would just explode with excitement to see.
Yeah, the energy in the room was pretty amazing.
Exactly.
They were all asking, where's the server?
Yeah. And we just kept repeating, there is no server. There is no server.
Yeah, it was a shame that we could not record that session, because there was also some really interesting questions there.
That's true.
We'll try to do prepare to capture next, but that's why we have asked Drew and Pedro to come here today and and share the demo again so that we could have a recording of it. So that if you want like to share it with other people that might be interested on so this is like a real-time application, convergence of data using CRDTs, and basically everything works on the browser with just IPFS and with peer-to-peer website. All right, we still have one more demo, and I hope I didn't ask Kumavis. Kumavis, are you still around?
Hey, yeah, how's it going?
Oh, all right, thank you. Yeah, so I saw that you added the demo for today.
Yeah, it's going to be really simple and really short. And I may have even presented this before. I'm not sure. It's been like months since I worked on this stuff last. So yeah, I'm just picking up the IPFS Ethereum integration again. So what I'm going to be showing today is the IPFS Ethereum bridge. The link is in the notes. It's if you look at the let me share my screen, of course. Okay, can you see my screen?
Yep.
Yeah,
okay, cool.
Thank you.
So here on the left, you can see the repo for the IPFS bridge, and it's really just this Docker compose file. So we've got two containers here, and one is vanilla parity. Parity is the Rust implementation of the Ethereum client, and they've been very kind as to merge into a sort of IPFS API. So they don't connect to the IPFS network themselves, but they expose all their hash address data using content IDs. So basically we enable that. And then I have this sort of custom JS IPFS client that uses parity as a data source. And so it's a bit messier than it needs to be because I needed to like copy pasta a bunch of code. But with a little refactoring on the JS IPFS side, it should be like 5 lines or so. Basically, we create an IPFS client, and then here we're kind of hacking in. When the node says it's ready, then we add this extra data store. And this data store is, it's just uses HTTP to hit the parity client. And actually it's in the, so I created this sort of wrapper module called hooked data store, hooked read-only data store. And so I just give it this function. It takes a SID and a callback, and I'm just saying like, oh, is this something that we possibly care about? If it is, then hit the parity client over HTTP, and then fail or return the result. And so what that looks like is over here. So first, we're going to hit the ask a parity client, what's the latest block? And it's going to give us a bunch of data here, and all we're looking for is the hash. And this is in the raw hex encoding. And so I'm going to use this little tool called ETH-IPLD to convert it into a content ID, and we want the block. So then we can, so this ipfs.lab.metamask.io is that custom JS IPFS node that reads from parity. And if I put the that new SID in there, it's going to give us this raw hex, raw binary response. And if I use that ETH-IPLD tool again, I can tell it to parse it as a block, and it will read the block data there. And we could manually start going down the state tree, like where all the account balances are stored. So yeah, right now that's a really manual process, but in theory you could use the IPFS DAG and just start pathing through things. And so that's the extent of the demo for today. And so that service is up and running and connecting to the normal network. So if your client can understand the Ethereum objects, you should be able to pull it off of the network.
It's pretty cool. So right now I can just like for any Ethereum hash that I receive, I can convert it to a CID, and I can fetch that block and add it to my JSIPFS node independently, right?
Yeah, so you can't do transaction receipts or transaction trees or transaction receipt trees, but everything else you should be able to look up. The node is also, it's not an archive mode, so it's like pruning, so it has to be relatively recent data or it's going to throw it away. That's, again, just some configuration, and DevOps could fix that part. But the parity client does not expose those other things, the transaction trees and stuff, just because it doesn't store them. It generates them as needed.
How big is the Ethereum blockchain nowadays?
Yeah, that is a good question. So in archive mode with like this like extra hash reversal database, just because that's the only statistic I have ready, it's about 200 gigabytes.
200 gigabytes, okay.
But again, that doesn't include those transaction trees and stuff, which
I was just thinking like it would be probably interesting to just like preload in a bunch of nodes the entire blockchain, or at least like just make it follow, so that like then when you are trying to traverse the Ethereum blockchain, you have multiple nodes to like fetch the blocks, and it's just faster for everyone.
Yeah,
and we probably can like host that in some of our nodes as well.
Yeah, that would be nice. I think I'll probably give this, once this is up and useful, I mean, maybe it's useful right now. I haven't really tried using it for anything intensive. There's some teams inside the consensus that would also spin up quite a few of these for us, so that would be nice. Yeah, the goal is to turn MetaMask into an Ethereum-like client eventually. Currently, we're just 100% trusting the hosted nodes to give us the data, and it has terrible caching properties because basically, once the block is changed, you don't know if your balance has changed or not. You have no hints there. Whereas here, you'd have kind of the Merkle tree, and as soon as you hit the same hash, you know that everything will be the same. So I have this sort of iterative working towards a light client where we'll start with, again, a trusted party just telling me what the latest block is. And from there, being able to traverse down the state tree over the IPFS network. That would take a lot of load off of our hosted trusted servers. Currently, we have over 60,000 users, and they're just like constantly pounding away at this server, at our hosted nodes. And so taking the heat off of them a bit by sharing that same information between peers. And so these 60,000 users, they're pretty much all Chrome extension installs, and so it's like always running in the background. So if we have a little lightweight IPFS node, it can share that data amongst each other.
Yeah, like it is always like that question, because you can have the node running, but you cannot like have WebRTC in a web extension, and then it's kind of like you can have the node, but you are still fetching from some central points. And like it makes it very interesting is when you have WebRTC, because then you can like just fetch from your nearest neighbor. We can go around that by having a node in a service worker and the node in the web extension, and with that be closer, like the one that gets WebRTC first, like if it's the extension or if it's the service worker, then we manage to give WebRTC to the rest of the web application, because then we can have just like two super peer nodes that one is running inside one context and another one is running at the other context, and they will just connect to each other. It is still an open problem though. It's still something that like we kind of like are dependent on browser implementation. But yeah.
I'm a little concerned how performant this is going to be when because you may need to do some some rather deep lookups. Like if you're something as simple as looking up a token balance may involve going from the block state root down to the account, and that could be several hops down the Merkle tree, and from there going inside that contract storage tree, and then like several more lookups. So if you have to do 20 lookups for a single value, that might not be practically performant.
That is where the discussion around something like next version of BitSwap or an improved version of BitSwap comes around, because then you can just like send your query to the other node, and if it's a node willing to cooperate, it can like try to resolve the query locally and understand how many nodes you have to fetch from, like, because right now, like if you, the way that it would work now, like you request the first node and you receive the first node, and then you realize, oh, I need to go deeper, right? And now you request the next level, and like you keep doing this back and forth. And it is possible to just like say, like, hey, here's like my destination. And then like the node tries to resolve locally, and like it just will give you the entire tree as far as it can get to you. And then like instead of like you having to do like 20 round trips to then understand, oh, now I have to go to another node, you just do one round trip, and then you realize, oh, now I have to go to some other node. But you would have to do that anyway if the data lives in some other part of the network. And then another thing that can happen is if you have nodes, as you have right now, that you trust, or nodes that are willing to pay the cost of being proactive in like caching stuff, I can send queries to like 3 nodes that I'm connected. If one of those nodes is kind of like this proactive, very friendly node, it can actually be the one like fetching that content for me from the network and then like replying all at once. So if you have like a node that's like in a very good location with fast bandwidth, like fast memory, that holds a lot of connections open and so on, then it might make sense for an infrastructure of an application to have that node being a friendly node to the rest of the application nodes that is able to do these queries and events.
Yeah, those would be huge improvements in the kind of performance we're going to see in the near term. Some other thing that might be nice is if you do that full request, like, hey, I'm trying to path all the way here, and be able to include the hashes that you have. Like you think this data is probably stale, but this is what you have, and then it only has to, it can meet you halfway because you already have the latter half of the data.
Meet you at halfway, because so like you would only request what, okay, I got it. The query you would send into the network doesn't need to be the initial one. It's just like the one that you are missing, like the remaining path from what you are missing, right? So if I'm like,
no, sort of the other way, because we have a Merkle tree and the state hasn't changed. Let's say I'm asking about your balance, and your balance hasn't changed, but a bunch of other things have changed. So the state is different, and so you don't know whether or not your balance has changed. But you can be like, here's the data I have for my previous balance, and I want to go down to my balance. And so it says like, oh, yeah, actually your balance is the same, but all this stuff changed in the middle. So here's the middle data where you can tell that your balance is the same. Does that make sense?
Got it. Yeah, it makes sense.
So it's a Merkle branch of like 10 nodes. The bottom 5 are the same, the top 5 are different, but you need to hear about the top 5 in order to be sure that the bottom 5 are different.
Yeah, I'm trying to think what would be the closest thing possible that we can do to support those kind of queries in BitSwap. Right. It is something like, so the way BitSwap has been built is very pluggable. You can even like in just IPFS to change the exchange and try different BitSwaps. I know that David Grissom is working on making BitSwap better. So if you guys want to talk more about that, like a GitHub issue, doesn't have to be now. But yeah, like it will be definitely very interesting to explore how we can inject those different strategies in BitSwap, especially in runtime, because nodes might have to change behavior at some point.
Cool.
I don't know if anyone else has thoughts on this. I know that like more people have been like thinking about BitSwap and how to optimize it.
Who the
I think it's probably better off for an issue at this point, but I've been doing a lot of work on BitSwap, as has David Grisham, not Diaz.
All right. Does this answer? I know partially because it's essentially yes. We need to think about it for that part. For the graph query where you send like the selector, the IPLD selector, and like then nodes are smart enough to like give you back more complete responses. That's definitely like very much on like the plan. We definitely know we want that, and we have a more clear picture of how to achieve that soonish. For the other part, for like syncing Merkle trees, it's like it is literally the case of like using Merkle trees to sync data, right? It is something that has been solved. It is just not a primitive within BitSwap itself. So we just need to figure it out how to like tune BitSwap to support those cases as well.
Yes, so I'm excited to start working on this stuff again. I got pulled into like core MetaMask, and we should also have Herman helping us as well on the Go side to make sure Ethereum's well supported.
All right. Yeah. I think like one good thing would be go through all of the issues that we have open in terms of like compatibility between peer-to-peer and the peer-to-peer MetaMask and IPFS and so on. It's just like review because a lot of things have been changed. Like a lot of things have been shipped. Let's see what is still missing and what is the right direction right now. Feel like there was an issue like parity to IPFS or IPFS, parity to IPFS, I think, on just IPFS. Let's like update the whole picture there.
Yeah.
Like just.
Yeah, totally.
All right. Any questions? Maybe we can like stop screen share so that like we can see everyone at the same time. I keep like going back and forth trying to see if I find hands. All right. Okay. If there is no more questions, thank you so much, Kumavis. It was awesome. Really excited. I feel this was an awesome call today. A lot of people have joined. We had 2 awesome demos. A lot of new building blocks for people to try on. Again, like if you are looking for ways to contribute, definitely check always the community repo, the nodes repo, and the waffle boards for the projects, because that's where you can like at least have a glance of where most of activity is. And if there is no more questions or thoughts, I guess we end this meeting. Thank you, everyone.
Great. Thanks, everyone.
All right. Thank you. Have a great week.
Thank you.
Thank you soon.
Thanks, guys.
Bye, everyone.
Cheers.
Bye-bye. Kuba, did the live streaming work well? Kuba? Oh, so... Oh, really? So...
YouTube. Okay, now